All right, on the gate. All right, I'm Doug, and today I'm doing my video presentation on the path of travel of light from basically outside into your brain. So I'm going to use today my 5 times size human eyeball model. So I'm a photon of light, blah, and I'm traveling right for your eye. So what happens? So first we encounter the human windshield onto the universe, the cornea. So a nice clear membrane keeps the bad stuff out, keeps the rest of what's supposed to be in there in. Nice and clear. Basically gets a squeegee from your eyelids from time to time to keep it clear and moist and free of debris. So we travel through there into the anterior chamber, which is filled with the aqueous humors. And then that reaches this thing right here, okay, inside of the iris. I'm going to separate these. Here we go. Ooh, sorry, guy. All right, so it travels through the anterior chamber into the lens, or through the lens. So a nice little hard piece of equipment for the human eye, and with the help of muscles around here, this gets focused in and out, and then that travels into this clear body, the retina. Looks like Dr. Kenny was correct. The retina is in fact clear. So then this is the posterior chamber, and it is filled with the vitreous humors. So then all of us photons, me and my other brothers and sisters, are getting focused via the fovea, and we go all the way through to the back of the eye. So, okay, let me remove that. Sorry, lens. All right, and then we go to the back of the eye, to the macula. I guess we'll call this the superior, and the macula, inferior. So this is the back of the eye, and this is where the magic really starts to happen. So we all get focused down to our light receptor package. So basically we're doing a swan dive into the back of the eye. We're diving through a number of layers of assorted nerve tissues until we reach the RPE, which is a pigmentation layer. So now I slam photon, blah, and me and my brothers and sisters, we slam into the back of the eye where we reach these pigment layers. And like a suntan, we change these pigments into different colors. And this changing color is a chemical reaction, and now we have converted this photon of light into chemical energy. Wow. So this chemical energy now rebounds back up this chain of command into the rods and the cones. So basically our photoreceptors. And then these rods and cones, whether it be color or black and white detection, these are then traveling through an axon layer. So basically these are tendril-like things which connect up to ganglions, the actual nerve cells themselves. And then once it hits the axons, or I believe that the gaps between the axons and the different axons, these are the synapses, and then this process turns it all into electrochemical energy, which is now readable by our nervous system. So basically these electrochemical impulses now travel through all these assorted nerve bundles, and they are all bundled together into blam, the optic nerve. Here we go, at the back of the eye. And so now we have this electrochemical information. It is now traveling at around 600 feet per second through the nerve bundle, and so then it gets separated into a temporal bundle, which is out here towards the ear. I guess that temporal may refer to the tympanic membrane, the drum in your ear, the eardrum, and the nasal. And then these get combined into something called the chiasm, where basically the neural fibers cross over, yet the temporal fibers keep going towards the back of the brain. So these all get processed down into the LGM. Let's call this a pre-video processor. So basically, this neurochemical optical information has now been converted into information. Now this is information we can start to use. It gives us information like where is this object in space and time, and what color is it, and can I reach it, and what is the actual size, what is the actual shape. So then this information, which was separate for a while, because this separation up until the chiasm, this difference in two different eyes, we want to preserve this difference to a point, because the two different images allow us to see binocularly. So this allows us to do things like depth perception and texture and all these other wonderful things. So now this combined neurochemical optical information is now on its way through the optical radii. So now it's traveling to the back of the brain, to the visual cortex, which is located in the occipital lobe, or right back here at the back of the head. And then this is where this optical information is now really processed. So basically, the photons of light, which started out here, and they pass through the eye, and then they get processed by the receptors, and then they get converted into chemical energy in the pigments, followed by electrochemical energy into the nerve bundles, into your synapses, your axons, your ganglions, which all then get bound up into optic nerves, and then they pass through the chiasm to maintain a certain amount of binocularness, and then they get processed for gross information in the LGM layer. And then when it reaches the visual cortex and combined with the occipital lobe, now it's like, oh, this is a lens, and it's here on the table. And based upon my estimates of where it is in time and space and what it is, and I want to clean up my table. So this is how I make my hand and arm reach out and gather it all together. And so basically, the neural cortex, the optical cortex, and the occipital lobe, this is where all this information is combined, so that I can make my body take this information and process it all together, so that I have one smooth flowing universe where optical information is processed into real life information. I hope this was clear and concise, and most important, correct. Once again, I'm Doug, and thank you for your time.